Okay, back talking about the metric system. We're on section 7.3 now. 7.3 is our section where we talk about mass and temperature. So if you'll follow along in your note packet with me, it says the kilogram, or kg, is commonly used to measure mass. The difference in mass and weight, we mentioned this earlier, but we'll say it again here, is that mass does not change due to gravity, but weight varies. For example, if you're on the moon, your weight will be very small. It's a little less pull of gravity, so you're not going to weigh the same on the moon, but your mass, you're still going to be there. Your mass is the stuff that's there, right? Your weight is that measurement that we have, the pull of gravity. So they are different. But for our purposes, we will assume that you're on Earth and weight and mass are basically the same. So we'll use them interchangeably, but I know they're different in case, that would come up like, oh, my teacher said they were the same or something. So my physics instructors here, they'd be upset if they thought I said they were the same, so just putting that out there. So note the base unit for conversion purposes is the gram. Whenever we're talking about our conversion scale, the moving between the basic units that we use in the metric system are meter for length, and liter for volume, and then gram is the root word we use for converting in mass, but it's so super tiny that kilogram's the one normally used to make enough significance to weigh something. So gram's super tiny. So that's what I'm noting here. The gram is a super tiny measurement, so most of our measurements are given in the kilogram unit, which is 1,000 grams. A gram is used to measure very small substances, such that would be measured in ounces, maybe something very tiny, like a nickel. There's that nickel again. I do still have my nickel I got out from the last video. If you put a nickel in your hand, the weight or the mass of that nickel would be 5 grams. A nickel weighs about 5 grams, and I can't even tell it's in my hand, so it's super tiny. A cube of sugar has a mass of 2 grams. And a large paper clip is 1 gram. So that's exactly, if you put a large paper clip, you can't even feel that. That's what a gram weighs. And we have milligrams, which are taking that and dividing it by 1,000. So a milligram would be super, super tiny. You wouldn't be able to detect it. The kilogram is used to measure what we would normally measure in pounds. A typical newborn weighs 3.5 kilograms, or that would be 7.8 in pounds. And that's kind of what you're probably used to hearing, like if you've had a child or your friends had a child and they said what their baby weighed, they probably didn't tell you how many kilograms, although they might have. They do give those measures, but we still tend to think in terms of pounds. An average man weighs about 75 kilograms. All right, next measure, the metric ton, T, is used to measure or express the mass of very heavy items. So that would be 1,000 when you times your kilograms by 1,000. 1,000 kilograms, you would get up to a ton. And it's a little larger than our customary ton. Our Old English customary ton is 2,000 pounds, so it's a little bit more than that, but they're similar. The mass of a large truck may be given in tons or tons, depending. All right, another conversion chart. In the last video, we talked about how a cc, or a cubic centimeter, a three-dimensional centimeter, or a cc, will hold a milliliter of liquid. And we talked about that's a common thing on maybe if you have to give, when my kids were little, I gave them 5 mLs of Tylenol, and I knew on my medicine dropper it would say an ml on one side and a cc on the other side, and that's why they're equivalent measures. So a cc holds an ml of liquid. And then the new part to our chart here is it weighs a gram. That liquid, that 1 milliliter of liquid would weigh 1 gram. The weight of a paper clip, you remember. The next one is a cubic decimeter would hold a liter of liquid, and that would weigh a kilogram. And then lastly, a cubic meter would hold a kiloliter of liquid, and it would weigh a ton, a metric ton, 1,000 kilograms. So if you're asked to do a cubic centimeter and convert it to liters, where these aren't in the same units really, we need this chart that we'll need to convert from this chart. And think about, well, what's liters in? Liter is a cubic decimeter. So if I could get 1 cubic centimeter converted into cubic decimeters is the same thing as a liter, and I would have it then, right? A cubic decimeter is a liter. And this we can do on our chart. That's what we did in the last video. We would talk about how we got meters, liters, and grams, the 3 base units. Then we got deca, hecto, and kilo. Then down the scale we have deci, centa, and milli. So if we're going from, so I see on my conversion chart that if I had it in cubic meters, a cubic meter is equivalent to kiloliters, if that's what it asks, or to how much it weighs in tons. So I would like cubic decimeters to be in cubic meters. So my question is, well, what is that? How many to convert from cubic decimeter to move it over to cubic meters? So now I can use my conversion chart. Cubic decimeters, cubic meters, that's deci to meter, that's 1 up. Notice that's up the scale. So I'm going from deci to meter. So I'm going up the scale, and that's 1 up. So up means moving the decimal to the left. And so we triple that because it's 3-dimensional. So 1 move from deci to meter is 1 move, but it's times 3. So 1, 2, 3. And so 0, 0, 2, 3 in cubic meters, and then that should be my answer. That converts it to, yeah, that should take care of it. So I was questioning myself there for a minute. Sorry about that. But yes, that should be your correct answer for that. All right, so that's how we'll handle. You'll need this chart to do some of these problems that are kind of special in converting from their solid form, their 3-dimensional form, to their liquid form, to how much they weigh. All right, next thing in your note packet. Let's do a fish tank. We have a volume, trying to find the volume of a fish tank. So that should be a 3-dimensional figure we're dealing with here. So keep thinking length times width times height. The volume of a 3-dimensional figure is its length times width times height. So we have a fish tank that is 1 meter long, so 1 meter this way, and it's 50 centimeters high, 50 centimeters, and then it's 250 in millimeters wide. So that's all over the place. We're going to have to convert those. So we can't times millimeters, times centimeters, times regular meters. It won't wind up being in the cubic units of any one of those. So we need to decide on what we want to measure it in. And that's kind of up to you. Sometimes it'll say in the directions. In this one, it did ask us to figure out how many liters. So to get it into liters. So liters is this part right here. It would be nice if these were all in decimeters. Then I wouldn't have to convert between these around. I could say liters is the same thing as cubic decimeter. So if all of these, this 1 meter was in decimeter, this 50 centimeter were converted to decimeters, and this 250 millimeters converted to decimeters, then I could take the decimeter times decimeter times decimeter, and that would be cubic decimeter, and I would have it converted into the liters is the same. So how do we do that? These are 1-dimensional. Aren't you glad we're just doing 1 dimensions here to get from each dimension, we're converting individually. So to get from meter to deci, remember from meter, deci's right below it. Deci, centa, milli. I keep erasing that and I keep needing it. You might notice. And then I've got deca, hecto, kilo. All right, so to get from meter to deci, regular D, not DAM is up here, but DM is 1 down. Down moves right, and we're just first degree on these, so 1 place right. So that's 10. Measuring just linear, just first 1 dimension. Then 50 centimeter to deci, centa to deci, that's an up move. Up is left, so from your decimal point, 1 left makes that 5. And then lastly, millimeter to decimeter. Milli to deci is 2 up. Up is left, so 2 left. Again, these are just first degree 1 dimensions, each dimension. And then I'm going to multiply that together. So we've got 10 times 5 is 50, and then 50 times 2.5. So multiplying that out, and I have this on your sheet, I'm cheating, is 125. length times width times height equals 125, and that is in cubic decimeter. Decimeter times decimeter times decimeter, what's times together is cubic decimeter, and we can tell on our chart a decimeter and a liter, exactly the same thing, so that is the ultimate answer. And there are other ways to get there if you're kind of questioning, you know, if you've thought another way to do it. You could have converted them all to meters and then had to move it, you know, on the scale with the 3 places. There's other ways to get there. The main thing is you get that right answer with your method. All right, so how much would this weigh in kilograms? Is the next question I have. 1 liter is 1 kilogram, so it would be exactly the same. We could say this weighs 125 kilograms. What if you were asked to weigh it in tons? Now I've got a difference to get from kilograms to tons that says there's 1,000 difference between a kilogram and a ton. It's 1,000 of those, so I'm going to need to move 3 decimal places. So we'd move 3 back. Since that's going up the scale from kilo, it's 3 more higher to get to the big measure of ton. So up is left, so 0.125 to get it in how many tons it is. All right, you have an activity next, so please pause the video and give some thought to those 2 problems. All right, so on this next one, it's asked you to do a fish tank again. It's 2 meters by 60 centimeters by 25 centimeters. And it says determine it in liters again. If it's going to ask me to do it in liters, I'd almost just as soon go ahead and just make it all in decimeters, because cubic decimeters works with liters. And if your question would have said in milliliters, I would have converted them all to centimeters, or kiloliters, I would have converted to meters. But anyway, this one said to find the answer in liters. So I see in this, these are equivalent. A liter is a cubic decimeter. So I will take each one of these and convert into decimeters using that linear scale that we've talked about. If we're just doing one dimension at a time, just first dimension, just this one unit, we move 1 place for every move on the scale. So deci is 1 below meter, so 1 right makes that 20. To get from centi to deci, that's up the scale a place, so it makes that 6. From centi to deci, again, same thing there, I guess. 1 place left, 2.5. Then we multiply that together, and that'll come out in decimeter times decimeter times decimeter, which we said is cubic decimeter. All right, so 20 times 6 times 2.5, that gives me 300, right? 300 cubic decimeters, and like I said, we know 1 cubic decimeter is the same as a liter, so that is equivalent in liters for our final answer of 300. All right, on number 2, we do it again. We do, it's the same thing, it's a swimming pool now though, instead of a fish tank, I guess. So this time we're doing a 3 meter wide pool by 6 meters long by 15 decimeters deep. Determine the volume in kiloliters. Oh, okay, so if I'm going to do kiloliters, I like to use this measure in the meters. So this is already in meters. That's good news. That's already in meters, but this one is not. What is 15 decimeters in meters? So deci up to meters, that's 1 move up. Up is left. So we're multiplying by 1.5. We multiply those 3 units together. It'll be in cubic meters. So let's see, that's 18, or 3 times 6 times 1.5 is 27 cubic meters. And cubic meters are kiloliters. So it's also 27 in liquid measure, and it weighs 27 tons if we needed to know.